Hello, everyone. This is Vivek here from Pentester Academy. And today I'm going to talk about 10 ways your containers can get hacked. So let's get started. Okay. So a little bit about myself. I've been an engineer. I've worked as a developer and then as a security person. And I've spoken at all conferences like DEF CON, Black Hat, ToolCon. I've discovered a bunch of attacks, authored a couple of books. And over the years, I've trained and spoken at over 20 countries. As I mentioned, some of my books on wireless security are available on Amazon. And, I'm the founder CEO of Pentester Academy and also Attack Defense Labs, where we have over 1,800 online lab exercises. So before we begin with the actual topic, wanted to go ahead and go through the basics of containers and specifically using Docker as a tool to run containers. So we are all aware that, Docker is a way by which we can package applications and deploy them predictably anywhere. And this is really where, under the hood, Docker works very differently, or rather containers work very differently than how virtual machines work. Now, during this presentation, I'm going to use containers, Docker containers, and Docker a bit interchangeably. So that's something I wanted to kind of mention up front. So in a virtual machine, we know that you have a dedicated operating system per virtual machine, and that does provide a lot of good isolation. In contrast, in containers, all containers running on a host share the same OS kernel. And on top of that, all applications as well as libraries and all of that are actually shared, are specific to each container. Now, the way isolation happens is using namespaces, as well as resource allocation happens like CPU, memory, etc., using C groups. So if you were to look at Docker threadscape, then you would actually find that there are really three parties here. The first is the Docker client, and this is really a tool which is going to talk to the container daemon and start containers, build, pull them, and all of that. And then you have the actual Docker host, and this is the host where your containers are actually running. And the third party is really Registry, where your Docker container images, etc., are hosted. So now, if we started looking at 10 different ways that your containers can get hacked, we'll start from some of the more easy ones and move into more difficult ones as we go along. So let's actually go from left to right. So the first one we are going to look at, of course, is more from the client's angle. So the client interacts with the Docker daemon, using various different techniques. It can go ahead and talk to a Docker TCP socket. It could go ahead and talk to some kind of Docker, I would say, overall Docker file which is kind of created on the system itself. So let's jump right in. So the insecure management software. So the first one really is that a lot of people end up using different container management software to go ahead and look at these infrastructures. And this is really where many of them do not secure these properly. Just like you would manage regular software, you kind of need to ensure that there are no weak passwords, you've updated it, API endpoints, etc., are not exposed. Because if this happens, then the entire host machine could be taken over. So let's actually look at a very simple demo of how this could work. So in the interest of time, because there are so many, I'm just going to go ahead and use a video to illustrate this. So we are using Portainer, which is one of the more popular, kind of Docker and container management tools. So let's actually jump right in. Now, when an attacker manages to go ahead and compromise a Portainer installation, right, whether it is weak passwords or insecure software, it becomes very easy for the attacker to actually go ahead and take over the host machine. So I've just moved forward a bit. Now, assuming that he's gotten a foothold on the container management software, it's really very easy to go ahead and compromise the host. And the way one can go about doing this is really looking at the list of Docker images available, picking any of these images, and then going about creating a container where he can end up binding the root file system. So in this demo, as you can see, we are creating a test container, and we've selected one of the images which is available on the system. Now, what the attacker can do at that point is select a volume which basically maps to the root file system of the host. So if you notice now, he's going ahead and mapping this to the root file system. And this way, when the container gets created, the root file system of the host ends up getting mapped into this container. So we can see the test container we just created is running. And let's go ahead, launch a shell. And because the root file system has been mounted, it's very easy for him to now inspect files, make modifications, or even use a simple chroot and do a lot of other damage. So which is really what we are doing right now. If you notice, we did a chroot, and now we are able to list the processes running on the host and all of that. Now, what we've done is, during the conference and up to 3 days after that, we've kept all of these demos free for anybody to try on our website. And if you do it successfully, you should be able to retrieve a flag in each one of these. Okay. So the second way really is exposing of the Docker socket itself. And what you'd find is that the Docker socket, is something you can expose over TCP. And this, if not properly protected, could allow an attacker to basically launch arbitrary containers and take over the Docker host. Now, the case could be kind of, two ways. One is, of course, all of this is a remote attack. The other is it's a local privilege escalation where a Docker socket is available to, other people who may be logged on to the host. So in the next example, I'm actually going to show you how you can easily take over the host by attacking an exposed Docker socket. In this case, we're assuming we're going to be using a low privileged account on the same system, but the exact same attack can also happen over a network if the socket has been exposed. So let's actually go ahead and run that example. So I'm going to go directly to the demo. So what we see here in this specific demo is that we have an account on the system, which is a low privileged account student. And now we can do a privilege escalation attack by going ahead and using this misconfigured Docker socket, which is available. So you can easily go ahead as a local account, look at all the listening processes on a socket, and we can see port 2375 is available, which is typically the Docker port. The best part really is Docker, when it exposes on TCP, is a simple, kind of REST-based API. So you could now very easily go ahead and use any tool to go ahead, inspect, and then run containers, etc. So as we can see here, we've gone ahead and done curl on that URL and looking at the version, which gives us a lot of version information. At the very top itself, we can see this says, the platform name is Docker Engine. And this proves to us that a Docker, engine is actually running, and, we are able to control it through this TCP port. So now, what we're going to do is very similar to what we did in the last demo. The only difference is that now we are going to be launching everything by connecting to this local TCP port, which would also have been a remote TCP port. So we are exporting Docker host so that we can use all our regular Docker tools. So now when we do a Docker PS, we connect to this port and we can see if something is running or not. We can do Docker images to see the list of images. And now, similar to the last demo, we can go about creating a Docker container where we are mounting the host file system. And the reason we kind of default to this technique, if available, is this immediately allows you to privilege escalate very, very easily. And it's a very common technique which is used when it comes to escalating and doing Docker breakouts. So we can see we've bound the host, so /host within the container. So now we can very, very easily go ahead list all the files, do whatever we want, do a very simple chroot, and do a lot more damage. So the important thing really is that you should not expose Docker socket, both locally as well as remotely, because this could lead to a very simple privilege escalation attack. So now the third one is similar, which is mounting Docker sockets into containers themselves. Now, when does this happen? So a lot of other Docker management tools and other third-party tools would need access to the Docker socket in order to get information and do various things. Now, this is a very, very insecure configuration. And you should be very, very careful whether you ever want to do this or not. But if you do this and that container gets compromised, then it's very, very easy to escalate by using the Docker socket. So let's look at a very quick demo of how we can do that. I'm going to fast forward a bit in the interest of time. Okay. So now we are inside a container, in which an admin has mistakenly gone ahead and mounted the Docker socket, or this could be a container of a tool which uses a Docker socket. Now, if the attacker is able to compromise this using any attack, then he can do a lot of damage. So in this case, we are trying to see if the Docker socket has been mounted, and we can clearly see that it has been. And now we can just use curl like we did in the last case, or if Docker tools are installed by default, then we can use them and do a similar privilege escalation attack. So I think the key three things that you need to check for is first, definitely, make sure that all your tools you use to manage Docker installations and container installations are protected. The second is the socket should not be available, without any form of security, both locally and over TCP. And the third is do not mount the Docker socket, inside a container. So you can see, just like the last case, we are now able to create a container by binding the root file system. And this immediately allows us to look at all the host files and then do further privilege escalation attacks like we did in the previous demo. So all of these labs, you can actually try out, during the conference, and as I mentioned, 3 to 4 days after the conference. So feel free to try and actually do a demo yourself. Now, the second part of the threatscape is the Docker host itself. And this is really where now let's try to explore a little bit more about containers and how attackers can compromise them. So typical Docker container does not have too many privileges. However, it is possible to go ahead and create what are called privileged containers. Now, in a nutshell, privileged containers, basically can go ahead and mount any device, can do a lot of other stuff which regular containers cannot. And these were primarily created, to go ahead and do tasks which might require, close to admin privileges or equal to admin privileges. Now, as you can imagine, it's a very, very bad idea to run any public-facing container as a privileged container. Sometimes we actually end up seeing people doing this as a matter of convenience, especially when they're working with various devices, rather than going ahead and creating rules for a specific device to be used within a container. They end up creating privileged containers so that this works in a very seamless way. So breaking out of privileged containers is actually quite easy. So let's look at a demo. We're going to just go a little bit further. So this is the lab starting. Okay. So here's an example where we started a lab and we are inside the privileged container. And you can easily figure out the capability that a container has by running the cap sh command. And by looking at this, you can clearly see that pretty much all capabilities are available, including the cap sysadmin capability. Because this is the privileged container, we can already see that, we see all the device files and all of that stuff. Now, the interesting thing is, just like in previous examples, we can now go ahead and mount the host file system and chroot into it, or change files, do whatever we want. Now, the way we can easily do this in a privileged container is because the device files are accessible to you. And you can clearly see that we can see that our base hard disk on the host dev SDA is available. And now all an attacker has to do is mount that. And once he does that, he's able to access files on the host and then use chroot and all of that to do further damage. So using privileged containers in public facing services is a very, very bad idea. If someone got a shell on the container, it's very easy to escalate. As you can see, we are able to do that and then grab the flag. Okay. So the next one is really containers with capabilities. So just like in Linux, people created capabilities so that they could go ahead and have more fine-grained partitioning of what root can do. It is possible to go ahead and use containers which have specific capabilities only, and not give it the whole dash privileged option where all privileges are given. Now, the problem really with capabilities is, just like in the old Linux capability thing, these capabilities are not really very mutually exclusive. So what can end up happening is some of these capabilities can actually allow you to do very simple privilege escalation attacks. So you can clearly see that some of these capabilities which are listed here, like sys raw IO, sysadmin, you can even see sys module, etc., seem to be quite powerful. So if you look at sys module, it says load and unload kernel modules. And you can imagine that if a container had the power to go ahead and load a kernel module, it could do a lot of damage. So let's look at an example where a container is running with the sys module capability and how an attacker can go ahead and do a privilege escalation attack. Okay, so let's go inside the container. So now we are inside the container, and when we run cap sh, we'll actually see that we have sys module capability. And sys module capability means you can create a kernel module and insert it into the kernel. So here is a simple bit of POC code which I'm about to show. And that POC code actually goes ahead and creates a user mode process running as root. And that process is going to go ahead and provide a reverse root shell back to the attacker. So as you can see, here is the kernel module source code. It's a very, very simple one. And in argv, you can see the actual command. So what this is doing is it's basically going ahead, connecting to a remote IP address and port. And once the connection succeeds, it's actually going to go ahead and run bash. So what happens is once this kernel module is executed, a user mode process is created as root. That process is now going to connect to TCP IP address, or rather IP address 172.17.02, which is the attacker's IP, and port number 4444. And once the connection succeeds, it's actually going to go ahead and start bash. So now let's actually go ahead with this. So we're going to create a makefile, compile the module, and then run the kernel module. So the compilation is on. Now, once the compilation is done, what we want to do is make sure that we can start a new terminal on the container itself, which can receive this reverse shell. So let's wait for the module to compile. Now started a duplicate terminal, and here I'm going to go ahead and do a netcat listener so that we can listen for the TCP reverse shell to connect to us. And now we are inserting the kernel module. and the kernel module gets inserted, the user space program runs, and we can see that we've gotten back a reverse shell on the system, right? So you can clearly see that by giving containers capabilities and not fully understanding what that capability could allow could lead to a very, very simple privilege escalation attack onto the host system. And here is an example. Now, there are many other capabilities, and most of them also end up leading to various privilege escalation attacks which can happen. Now, a couple of the next ones, I don't have specific demos, but they're easy to understand. So sharing host namespaces. Now we know that isolation in container happens using different namespaces. Now, unfortunately, if you have the host namespace shared with that of the container, it might be possible to go ahead and cross over, to the host depending on how the namespace has been shared and what all that allows the container user to actually do. So this is something you may find a lot lesser, which is happening. But if you do this, you have to be very, very careful. As you can see, some stuff like IPC, network, etc., is prone to very easy abuse. Now, the next one is really low-level container, daemons as well as container runtimes. So I'm going to pick up containerd and runc together and then show you an example with runc. So if you look at a typical container installation with Docker, what you'd find is there's a Docker client. The Docker client talks to Docker daemon, which in turn is going to talk to containerd, and which in turn uses runc to actually create the container which ends up running. Now, if on a system you have containerd or runc available and not sufficiently protected, then a regular user could actually leverage containerd and runc to go ahead and do a privilege escalation attack. So I'm going to take both of these examples together. As I mentioned, you can use either one of these to go ahead and do an escalation attack. So let's look at a demo. Okay, so in this specific example, what we're going to do is we have access to a container which has runc installed. So runc is the container runtime. And what we can actually do is, we don't even need any Docker containers or any images or anything to be pulled. We can first go about creating a dummy specification file. Now, typically when you use tools like Docker, they would end up finally creating the specification files and everything that is required, and then pass it to runc in order to create the actual container. Now, we don't even need to do any of it. What we can do is we can create a dummy specification, and in that specification, we can tell runc to go about mounting the root file system and basically making that the file system in the container. Now, by doing that and then getting access to the container, we are back to what we were doing all through, which is access the host files, as well as then run pretty much commands which can go ahead and modify and tamper them. So we've run a very simple command. Kind of go back. There's a slightly more involved example. So runc spec creates a dummy container specification file. Now, if you open up this specification file, you'll actually find a lot of stuff in here. Now, this specification file is exactly what tells runc on how to set up the container, right? What is the first process to run? What is the path? What are the capabilities? What are device files to be mounted? So on and so forth. Most of this, when we run high-level tools like Docker, are completely abstracted away, so you don't even know that this even exists. But finally, this is what it kind of distills down to. And these are the raw components of the OCI specification, which get used to create the actual container. So now what we can do as an attacker is basically add a new mount point. And in this mount point, we basically say that we want to mount the host file systems, from root into the container. And you can clearly see over here, what we mention is, we want a bind, and the source is basically the root file system, and the destination is also the root file system of the container, right? So once we do this, now we can tell runc to create a container. And you notice all we did was create an empty container, an empty directory. And now we are running runc along with run demo. And what this does is this is going to create a container. And if you do an ls, you'll actually find that we are able to go ahead and fetch files from the root file system. So this is an example where if low-level container, runtimes like runc or containerd are available, and a low-privileged user can access them, then he could easily privilege escalate and become root on the system, or at least get access to the files and all of that very, very quickly. So the last couple are very easy to understand. So there aren't any demos, but I can just run you through them, which is the registry itself. Now, a lot of enterprises seem to be, trying to go ahead and create their own local Docker registries. Many of them, even within their AWS account, just so that they can have their own private registry, and all the pools and everything can happen within the same, I would say, network itself. However, this is a very, very bad idea. The biggest problem really is that most Docker registries are insecure out of the box, which means if an attacker can get access, he can very easily backdoor these images. And if these images are backdoored and they get pulled on your servers to run, then all your servers could end up getting kind of compromised. And this can further also lead to Docker image secrets being leaked. So depending on how you're building your Docker images, keep in mind that Docker images are nothing but layers of file systems, right? You have a bunch of read-only layers, followed finally by a read-write layer, which is the actual container layer. Now, the biggest issue really is that all these layers go ahead and mask layers below them. So if you do not know that it is possible to fetch these layers individually from a registry and then inspect them, then while creating a container, you may have left behind some interesting secrets or something or the other, which an attacker can then recover by looking at which files got masked in lower layers. So this is really where I think when it comes to the registry and Docker images that you're deploying, you need to be very, very careful and aware that this can actually happen. All right, fantastic. So this is what I had in mind, for this presentation. The best part really is, most of these examples you can try live on the website by just going there. I've put in the links, and these are completely free to play. So thank you so much. And if you have any questions, more than happy to take it, or you can email me at vivek@pentestacademy.com.